energy consumption. So we all know that food provides our body with energy and the nutrients for growth and repair. And food energy is a form of chemical energy and is measured in kilojoules. And a kilojoule is 1,000 joules. And the common unit for food used to be the calorie. So you'll see that lots of people still talk in calories, but the standard international unit is the kilojoule. And most packaging in Australia has the energy consumption in kilojoules. And there is one thing we need to know, that 1 calorie is equal to approximately 4.84 kilojoules. So we all know that if you consume a lot of food with a high calorie rating, you may be getting more energy than you need. And this excess energy is stored in fat. So why is this a mathematical? Well, what we need to be able to do is convert units of energy. So I've put the 3 units here. We've got kilojoules, which you're used to seeing. So what we have is our base unit of the kilojoule. And we know that there are 1,000 joules in a kilojoule, and there are 1,000 kilojoules in a megajoule. And our conversions look like this, and there's something that's very easy to use. So we just need to know that there is 1,000, and we need to know that there's megajoules, kilojoules, and joules. So if we're going to be looking at doing this, here I have my first example, which is just simply use this conversion to make these changes. So I'm going to get you to pause the video now and have a go at doing that, and then come back and have a look at what the answers are. So you can see the first one is 0.3 kilojoules. The next one is multiplied by 1,000, I get 14,000 kilojoules. I'm going now from calories to kilojoules, and I know that 1 calorie is 4.184 kilojoules, so 82 times 4.18, and I get 343.088 kilojoules. Now I'm going from kilojoules to calories, so 1,600, I'm now dividing by 4.18, and I get 382.4 calories. And I'm now going from megajoules to calories. So to do that, I need to go to joules first, so I multiply by 1,000 to get to joules. And that gives me 170 kilojoules. Then I do 170 divided by 4.184, and I get 40.6 calories. And that's how easy it is. Now the next part is we're just going to look at a table. It says the number of kilojoules your body requires each day depends on your age, gender, and lifestyle. Answer the following questions using the table. Jenny is 18 years old. How many kilojoules does she need each day? Well, she falls into this age group. She is a female, so she needs only 9,000 kilojoules per day. Now, Mitchell is 25 years old and he works out at a gym for 2 hours, and the workout uses 2,500 kilojoules per hour. So that means he has some extra that he's allowed to eat, because he uses 2,500 kilojoules each hour and he exercises for 2 hours. So that means in his diet he's allowed an extra 5,000 used in 1 year kilojoules.
75 times 5
so
times
now if I look at the table, Mitchell's 25, so he fits into this same age bracket. So he's allowed.
And I'm going to divide that by 1,000 to make it into kilowatt hours. So I get 136.
To maintain his weight,
kilowatt
he needs to
hours.
consume 12,000.
So now the cost of electricity is
plus this extra 5,000 from working
I'm going
out,
to multiply that,
which means he's
by
able
the
to
cost,
consume
which is
17,500 kilojoules.
And then I get 35.3.
The other thing that we should be able to do in this course is just to be able to
I know that
read
money has to be 2
label.
decimal places, so I get.
And you've all seen these food labels
35.33.
because they're on everything that we
Now for the
need,
compact
that we
fluorescent.
eat. So
Electricity
I'm
in
going
1
to give you
year
time
is
to look at your
10.5
notes and
times
to have
5
a look and make
times
sure that you
360.
understand what every
So I get
part of a food label is saying.
19,162.5
And then there are a
watt
couple
hours,
of questions. So
which
I'd
is
like you to pause the video,
19.1625
answer the
kilowatt
questions,
hours. So
and
I
then you can
divided
come
by
back and
1,000.
see the answers.
The cost of electricity used is 19.
So now that you're familiar with the label, we can answer these questions. What is a serving size? Well, it's 30 grams. You must
and I get
be very aware of what the serving size is. So you
which
know
is
how much you're
$4.95.
How many kilojoules
So you can
per
see
100?
why we have
Tells you
moved to the compact fluorescent,
1,441
because
kilojoules.
they cost
What is the
us
amount of fibre per
significantly
serve?
less
Well,
money.
there's 6.4 grams of fibre.
I've
And
also
how much
put down a point
saturated
here that
fat
says
per
washing
serve
machines,
is
clothes dryers,
0.1
fridges and
grams.
freezers, televisions
And that's all there
dishwashers and
is.
other appliances
I'll see you
account
later.
for 25% of household bills. So looking now at example 4, it says calculate the lifetime running cost of the following televisions using 30 cents per kilowatt hour as an estimate for the cost of electricity and assume that the average lifetime of major appliances is 10 years. So if I was going to look at this, for my Sony TV, if I'm going to look at my lifetime running cost, what I'm going to do is I have the energy consumption is 319 and it costs me 30 cents, so that's 0.30 and 10 years. And so you can see that over 10 years, my television is going to cost me, apart from what I bought it, an extra $957. So I'm going to do exactly the same for the next one. So what you could do is pause the video and see if you can do it without me. So the lifetime running cost is going to be, in this case, same thing, 388 times 30 cents times 10 years. And I end up with this television costing me $1,164. Now, the other thing that uses up power is the fact that all of our appliances nowadays have a standby mode. And that standby mode means we are still using power even when the television or anything like that is not plugged in, like the cordless phone. So let's have a look at doing this last question. Find the power consumption of a cordless phone on standby. Oh, it said, what is the standby mode for a phone over a year if the electricity is charged at a rate of 28.05 cents per kilowatt hours? So power consumption is equal to 3 times 24 times 365, which gives me 26,280 watt hours. Which I'm going to divide by 1,000 to make 26.28 kilowatt hours. And therefore, the annual cost is going to be that 28.28 multiplied by the cost, which is 0.2805. So remember to change that into dollars. And I get 7.371, etc., which is $7.37. So remember, that's just one appliance that is on standby mode. And you might want to think about all the appliances in your house on standby mode and what that might end up costing you. If you've got any questions, you know where to find me.